Hey everyone, and welcome to another deep dive with us. This time, we're strapping in for a ride with the Voyager missions.
The twin probes that really changed how we look at space exploration.
That's right, we're talking groundbreaking discoveries, a whole lot of firsts.
And even a message in a bottle for any aliens out there.
Pretty cool, right? So, to kick things off,
What makes the Voyager missions so audacious?
audacious. Okay, I like it.
Is that when they were first dreamed up?
Way back in the 70s?
Yeah, we barely knew anything about the outer solar system.
Like we're talking blurry telescope photos,
Yeah,
right?
exactly. But scientists, they saw this once-in-a-lifetime chance.
Upon what chance?
A rare planetary alignment.
Okay, how rare are we talking?
This alignment, it only happens every 176 years.
Whoa, 176 years. That's like longer than most tortoises live.
It is. And what made it so special is...
Let me guess, it helped the probes get around.
You got it. Jupiter, Saturn, Uranus, Neptune, all lined up.
So NASA could use their gravity to boost the Voyagers along.
Like a cosmic slingshot, yeah.
Yeah.
That's brilliant. Without it, the probes wouldn't have reached the outer planets.
Let alone interstellar space, no way.
So, first stop on this grand tour, Jupiter. Voyager 1 got there in '79.
And sent back pictures that blew everyone's minds.
I bet. What did we learn from that close encounter?
Well, for one, we saw Jupiter's clouds in detail, the storms.
I've heard about those storms. Intense, right?
Oh yeah, and then there's the Great Red Spot.
What?
The Great Red Spot, this massive storm.
How massive are we talking?
Big enough to swallow Earth whole.
No way! Okay, that's one sight I'd skip on a space cruise.
It has been raging for centuries, though, and Voyager.
It helped us understand how these storms work.
For the first time ever, yeah.
That's pretty amazing. But Jupiter's got more than just a giant storm, right? What about its moons?
Ah, the moons. They're a story in themselves.
What, are they like little mini planets?
In a way, yeah. Voyager gave us our first real look at them.
Any standouts?
Oh, for sure. Io, for instance.
What's special about Io?
Well, it's incredibly volcanic.
You mean like active volcano?
Erupting all the time. The
Yeah.
first time we saw volcanoes.
Anywhere besides Earth.
You got it. Completely changed how we think about.
Whether other planets or moons could be geologically active.
And if they are, well, then maybe they could support life.
Wow. Volcanoes on another moon? That's just wild. Any other moons as dramatic as that?
Well, how about a hidden ocean?
Wait, seriously? Where?
Europa. This moon's covered in ice, but Voyager's data suggested
There's liquid water underneath.
a huge ocean, maybe even bigger than all of Earth's oceans combined.
That's insane. Okay, so why is finding an ocean such a big deal?
Think about it. Water is essential for life as we know it,
So finding it on another world means there's at least a chance.
that some form of life could exist there too.
Talk about a deep dive. Okay, so after Jupiter, Voyager 1 went on to Saturn, right?
That's right, and of course we all know about Saturn's rings.
Yeah, I can't imagine what it was like to see them up close for the first time.
Voyager 1 captured them in stunning detail.
But the images, they also showed us something else, right?
Yeah, the rings aren't solid.
Right, I always thought they were like one giant disk.
Nope. Turns out they're made of billions of tiny ice particles.
Billions. So like each one's a little moon orbiting Saturn.
And it's like a giant cosmic ice ballet. Mesmerizing, really.
Wow, billions of icy particles. That's mind-blowing. So what about Voyager 2? Did it just follow the same path as Voyager 1?
Not quite. Voyager 2 took a bit of a detour, you could say.
V2 tour. Where?
Uranus and Neptune. It became the first, and so far, only spacecraft to visit them.
Seriously, we haven't sent anything back since.
Nope. So all those close-up images we have of those icy giants,
Those are all thanks to Voyager 2.
that's right, a true pioneer.
It's amazing that we got to see those worlds up close even once.
You know, a lot of people lump Uranus and Neptune together.
They are both ice giants, right? But Voyager 2 showed us.
They're actually very different.
Like how?
Well, Uranus is tilted on its
I
side,
remember hearing about that, like it's spinning sideways.
and Neptune has these crazy supersonic winds.
It's incredible to think how much we learn from those flybys.
Yeah, Voyager really opened our eyes to the diversity of the solar system.
We've come a long way from those blurry telescope photos, haven't we? But here's something I've always wondered. The Voyager missions, they were initially just supposed to explore the outer planets, right?
That was the plan.
But then...
Then they just kept going.
Wait, so this already super ambitious mission, visiting 4 giant planets...
It got even bigger.
Yeah, how'd that even happen?
Well, remember that planetary alignment I mentioned?
The one that gave them the gravity assist?
That's the one. It gave Voyager 1 and 2 enough momentum.
So that they could escape the sun's gravity.
Exactly. They're now on a one-way trip out of the solar system.
Hold on, escape the sun's gravity. There's a point where the sun's influence just stops?
Yep, there's actually a boundary called the heliosphere.
What's that?
Think of it like a giant bubble.
What's it made of?
It's created by the solar wind, this stream of charged particles flowing out from the sun.
And this bubble, it protects us from stuff in space.
Yeah, from harmful cosmic radiation.
Okay, I'm picturing this vast bubble surrounding our entire solar system.
And then the Voyagers, bravely venturing beyond it.
Into a whole new realm.
And that's exactly what happened.
So, Voyager 1 crossed this boundary, this heliosphere.
Back in 2012. Became the first human-made object to enter interstellar space.
Wow. Voyager 2 followed a few years later.
In 2018.
That's huge. Stepping outside the sun's influence into a region shaped by other stars.
We were no longer just exploring our solar system.
We were venturing into the galaxy.
Yeah, the one way to put it, yeah. A whole new chapter in exploration had begun.
Incredible. So now we've got these two little explorers way out there in interstellar space.
A place totally different from our cozy solar system.
Yeah, what's it like out there? Besides, really big.
It's a wild place, that's for sure. Filled with cosmic rays, magnetic fields.
Okay, those sound kind of intense.
They are.
Mm.
And there's this thin soup of particles called the interstellar medium.
Interstellar medium. What's that like?
You can almost think of it like a cosmic fog, but it's made of gas, dust.
Dust. Like space dust. Isn't that what makes nebulae so pretty?
Some of it, yeah.
Yeah.
But this dust is different. It's got bits of stardust in it.
Hold up, stardust? Like from exploded stars?
Exactly. Remnants of supernovae floating around out there.
That's incredible. But also kind of harsh, right?
Aye.
I mean, how are the Voyagers holding up and all that?
It's definitely a tough environment. They've had to deal with extreme cold.
I can imagine being so far from the sun.
And intense radiation. Plus, there's always the risk of micrometeoroids.
Micrometeoroids, what are those?
Tiny particles, but zipping around super fast.
Yeah.
Like little cosmic bullets.
Yikes. So are the probes all banged up?
Oh, they've taken some hits over the years, for sure.
Yeah.
Their exteriors are definitely showing wear.
I mean, it has been like, what, almost 50 years?
Close to it, yeah. And their instruments are aging, power's running low.
But they're still functioning.
That's the amazing part. They're still sending us data, billions of miles away.
How is that even possible? Those nuclear batteries can't last forever, can they?
You're right, they can't. But the engineers who designed the Voyagers, they were brilliant.
What did they do?
They built in backup systems, redundancy for key components.
So if something failed, there was a spare ready to go.
Exactly. Plus, they used materials that could withstand, well, basically anything space could throw at them.
Like a cosmic version of that old pickup truck that just keeps running.
That's one way to put it.
Mhm.
And yes, even from beyond the heliosphere, we're getting data.
Wow. So what kind of info are we getting from interstellar space?
We're learning about the density of the interstellar medium, its temperature.
And what it's made of, right?
We're also detecting cosmic rays, those high-energy particles from supernovae.
So like explosions that happened millions of years ago, maybe even in other galaxies.
Potentially, yeah. And we're studying how those cosmic rays interact with the interstellar medium.
So it's not just pretty pictures anymore.
Not at all. It's hard data telling us about a region of space that was a total mystery before.
So like, are we mapping the galaxy now?
In a way, yeah. We're getting a better understanding of interstellar magnetic fields.
Magnetic fields, those are important, right? For protecting us from the sun's radiation, I think I remember.
And also for shaping the structure of galaxies, influencing star formation.
So much going on out there. It's kind of mind-blowing to think that two little probes launched in the 70s.
They're giving us this kind of knowledge.
It is. But I gotta admit, knowing they're slowly losing power out there.
It's a little bittersweet, isn't it?
Yeah, it is. Is there a point where they just stop? Like go completely silent?
Eventually, yes. Their instruments will shut down one by one as the power runs out.
I guess that's inevitable. But even after that, their journey doesn't end, does it?
Nope. They'll keep drifting through the galaxy, essentially forever.
Wow. So even after we lose contact, they'll still be out there.
Voyaging on like silent ambassadors from Earth.
It's kind of poetic, you know?
It is. But let's not get too melancholy just yet. They've still got a lot to teach us.
That's true. Think about everything they've already shown us.
Voyager 1 at Jupiter with the Great Red Spot, the volcanoes on Io.
And that possible ocean on Europa, that was huge.
Definitely. And then Voyager 2 going on to Saturn, giving us those incredible views of the rings.
And then onto Uranus and Neptune, the only spacecraft to ever visit those icy giants.
It's remarkable to think about all that they've accomplished.
Truly groundbreaking. They've shown us the beauty and diversity of our solar system.
Pushed the boundaries of our knowledge and inspired countless people.
And then they went beyond into interstellar space, proving that we can reach the stars.
A truly incredible legacy.
Absolutely. But there's one more thing we have to talk about, right? The golden records.
Yes, the messages in a bottle.
It's like something straight out of science fiction, this idea of sending a message to aliens.
But it's real. Those records are out there, attached to the Voyagers.
So what's on them? Like, what did we decide to tell the universe about ourselves?
Well, think of them as time capsules, a snapshot of humanity from the 1970s.
Okay, I'm intrigued. What kind of stuff did they include?
A little bit of everything. Greetings from people all over the world.
So, like, different languages.
55 different languages. And then, sounds of nature.
Like what? Birds singing, waves crashing.
Exactly. And music, too.
What kind of music?
A wide range. Classical music like Bach, Beethoven.
Okay, so sophisticated stuff. Anything else?
Oh, yeah, for some more modern music, too. Chuck Berry, for example.
Chuck Berry. That's cool. So a mix of highbrow and popular culture.
And even scientific information encoded in the grooves of the record.
Wow. So, like, if aliens find it, they can learn about our math, our physics.
That's the idea.
But how would they even know how to play the record?
Each record comes with a stylus and instructions etched onto the record itself.
Instructions? How do you explain that to an alien?
They use diagrams and symbols, things that any technologically advanced civilization should be able to understand.
It's like a cosmic IKEA manual for playing Earth's greatest hits.
That's a pretty good analogy.
It's amazing to think that those records are out there, drifting through the galaxy.
Carrying a message of hope, curiosity, our desire to connect.
Who knows, maybe someday some alien civilization will find one.
Hear our story.
Okay, so we've talked about the Voyager's epic journey, their mind-blowing discoveries.
From the gas giants to interstellar space.
Right, and even those golden records, the messages for aliens, it's all incredible.
Truly a testament to human ingenuity and our thirst for knowledge.
Absolutely. But as we wrap up our deep dive here...
It's worth reflecting on the Voyager's legacy. Not just out there in space.
But right here on Earth, right?
Yeah.
How have these missions changed us, how we see ourselves?
Well, scientifically, they've revolutionized our understanding of the solar system.
Before Voyager, those outer planets were just dots in the sky.
Blurry at best.
But Voyager gave us a close-up look, revealed them as these dynamic worlds.
Each with its own story, its own personality almost.
Yeah, like Voyager introduced us to the solar system's extended family.
All those quirky aunts and uncles we never knew we had.
Exactly. We saw Jupiter's giant storms, Saturn's rings up close, Uranus tilted on its side.
Neptune's wild winds. It was a revelation.
Totally changed our perspective, showed us how diverse our little corner of the galaxy is.
And the discoveries went beyond just the planets themselves, venturing into interstellar space.
The Voyagers started sending back data from a region we knew nothing about.
The interstellar medium, the magnetic fields, the cosmic rays coming from distant supernovae.
So we're not just talking pretty pictures anymore.
No, we're talking hard data about the galaxy, the forces that shape it, the very elements that make up our planet.
Wow, the stuff that we're literally made of.
It all ties back to those processes happening out there, and the Voyagers helped us understand that connection.
It's pretty mind-blowing to think about it, that two little probes launched decades ago could have such a profound impact on our knowledge.
It speaks to the power of human curiosity, our ingenuity.
And the dedication of all those scientists and engineers who made it happen.
Absolutely. They pushed the boundaries of what we thought was possible, inspired generations to come.
And it's not just the science, right? The Voyagers have captured our imaginations, inspired art, music, movies.
They become a symbol of our ambition, our yearning to explore.
That drive to reach beyond the familiar, into the great unknown.
There's that iconic image, the pale blue dot, remember that?
The one Voyager 1 took of Earth from billions of miles away. How could I forget?
Our planet, just a tiny speck in the vastness of space.
It really puts things in perspective, doesn't it? Makes you realize how fragile our home is.
Carl Sagan's words about that image, they still resonate today, a call to cherish this pale blue dot.
Our only home, and it's up to us to protect it.
The Voyagers, they helped us see that, understand our place, in the grand scheme of things.
It's humbling, for sure, but also inspiring, right? Knowing that we can send these little emissaries out to explore on our behalf.
And let's not forget those golden records attached to the Voyagers.
The time capsules, hurtling through interstellar space. Maybe someday an alien civilization will find one.
A message in a bottle, carrying our hopes, our dreams, our music, our science out into the cosmos.
It's a testament to our belief that we're not alone, that somewhere out there.
There might be others looking up at the stars, wondering the same things we are.
It's an incredible story, isn't it? Two small probes launched back in 1977.
Traveling farther than anything we've ever built, exploring worlds beyond our wildest dreams.
And they're still going. Their journey continues even as we speak.
A testament to the enduring spirit of exploration.
So as we wrap things up, what would you say is the biggest takeaway from the Voyager missions? What's the one thing we should carry with us as we continue to explore the cosmos?
I think the Voyagers have shown us that exploration is about so much more than just gathering data or discovering new places.
It's about pushing our boundaries, challenging our assumptions, understanding our place in the universe.
It's about recognizing how interconnected everything is, from the tiniest particles to the vast expanse of space.
And that our actions here on Earth, on this pale blue dot, have consequences that ripple outwards.
We need to be mindful of that as we continue to explore, to learn, to reach for the stars.
It's about hope, curiosity, that never-ending drive to understand what's out there.
The Voyagers embody that spirit, and their legacy will continue to inspire us for generations to come.
Beautifully said. So everyone, keep looking up at the stars and remember those two little probes.
Out there in the vastness, still exploring, still sending back whispers from the unknown.
Thanks for joining us for this deep dive into the Voyager missions. It's been an honor to share this incredible story with you. Until next time, keep exploring.